Hi, we're going to talk about properties of imaginary numbers. Imaginary numbers come into play when we can no longer deal with real numbers. Real numbers being any kind of number you've dealt with your whole life in math class, especially dealing with the real number system, dealing with natural numbers, whole numbers, integers, rational, irrational. Um, there were some numbers that we weren't able to use yet. One of those numbers is this I, and it comes into play when we're dealing with a square root of a negative one, square root of a negative rather. If you take this and you plug this into a calculator, you're going to come back with an error message and says, we cannot do this. Uh, Somewhere along the line, someone said, no, we can do this. That's where I comes from. So let's look at these. Whenever we have I raised to an exponent, we can simplify it. When we use some of the rules of exponents to help us with that. Anything raised to the 0 power, according to exponent rules, we know has to be a 1. Okay, so if ever you see I to the 0 power, instead of that, we're going to put 1. If you have anything raised to the first power, that says you only have one of those things. So we just say I. Uh, I squared is where things get a little complicated. There is a definition. There is a long-winded way to find it, complicated way. Let's just accept that it's there. And we're going to say -1. Just accept that it's a -1. When you accept that, rather than going through the long-winded excuses and rules, I can now use these two to find this and everything else. So I to the third. I to the third is a combination of I squared and I to the first, because with our rules of exponents, you add these two exponents, you're going to get 3. But what is I squared? I squared is the same thing as saying -1. I to the first is the same as saying just I. And if I were to simplify that, I'd get -I. If you ever saw I to the third power, instead, you would write a simplified version of just -I. Now we can use that same thought process with I to the fourth. I to the fourth, we could say, is a mix of I squared and I squared. Add those two exponents, you get that 4. Well, I squared, again, -1, -1. Multiply these two things together, and you end up with a +1. So if you ever saw I to the fourth, you can simplify it to just I. Now, we're going to do the same thing with all these other numbers here. So we're going to try I to the fifth, which is a combination. You can come up with any combination. You could say I to the fourth, I to the first. You could say I to the second, I to the third. As long as those exponents add up to 5, we can get there. So let's simplify. Let's see what happens. I to the fourth is the same thing as saying 1. I to the first is the same thing as saying I. What is 1 times I? It is just I. What if I picked a different combination of exponents? What if I said I to the second, I to the third? Well, then I'd have I to the second is the same thing as saying -1. I to the third is the same thing as saying -I. A negative and a negative gives you a positive 1 times I, just I, or a positive I. That's what we have there. Uh, let's try it with I to the sixth. I to the sixth, we can come up with I to the third, I to the third. These two things add up to give us 6. Or we could do I to the fourth, I to the second. Again, exponents add up. And you could do any combination. And let's just see where they end up with. I to the third is -I, -I. If I were to multiply these together, negative and negative is a positive. I times I is I squared. Now we came up with an answer of I squared. Can you simplify that? Yes. If I see I squared, it's the same as -1. Okay. How about I to the fourth I squared? Again, these two exponents add to 6. So this is just another way of trying to simplify the same answer. I to the fourth is 1. I squared is -1. Positive 1 times -1 equals -1. The same thing you just got there. Now, if you kind of take a look at what's going on here, we sort of have a pattern. I -1, I 1. I -1, I -1, these match up. So there's got to be a guess. If I were to do these same sort of operations, I'm going to come up with a -I. And then after that, I'm going to get a 1. And all of a sudden, we start to repeat ourselves. We've got these 4 numbers that keep repeating themselves. So I could keep going and say I to the 9th, I to the 10th, I to the 11th, I to the 12th, and they're going to keep repeating. We're going to get I, -1, I, 1. You can, if you're not so sure, you could keep coming up with all those combinations. Okay, how does this help us? Well, what if we wanted to figure out and simplify something like I to the 25th power? Well, we could just keep counting. You could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And you're going to get I. Okay. Do I want to keep counting? Because what if I get larger numbers like I to the 40th? I could just 4, 8, 12, 16, 20. Wait a minute, 20. If I kept doing that again, I get another 20. We'll be at 40. So I'm going to get I to the, or just 1. That's doable by just counting. But what about if I've got really large numbers like I to the 265th power? I don't want to count 265 times. There is another way you could do this. So we have 4 options that we're left with. I, -1, I, and 1. And those 4 options keep repeating themselves. You could take your exponents and divide them by 4. Divide them by 4. So if I divided it by 4, if I said 4 divided by 1, as a decimal, that's 0.25. If I said 4 divided by 2, I get a decimal of 0.5. If I said 4 divided by 3, a decimal of 0.75. And then 4 divided by 4 would be an answer of just 1. What if I did the next round? 5 divided by 4 would be 1.25. 6 divided by 4, 1.5. 7 divided by 4, 1.75, and keep going. 2.0. And then if we kept doing 9, 10, 11, and 12, you're going to get 2.25, 2.5, 2.75, and then 3. What am I trying to show? Well, these 4 numbers repeat, but also look at the decimals. The decimals repeat. So if I wanted to say 25 divided by 4, I'm going to end up with something 0.25. If I said 40 divided by 4, I'm going to end up with 10 point, or just straight up 10, which would be 1. 1. If you end up with a 0 down there. Now, use that with this 265. If in the calculator we said 265 divided by 4, you're going to come up with an answer of 66.25. What does 0.25 mean? 0.25 means that's going to be an answer of an I. And we could do this for any size exponent. Now, this is just a beginning stage of what we're about to do with i's. So if you ever see an I raised to a higher exponent, we need to simplify it to one of these 4 options. And that is properties of imaginary numbers.